Hello everyone, this is INE Foundation Lab 3 and Section 2.5 Spanning Tree. Okay, let's refresh Spanning Tree concept and I will come back and conquer this section. Okay, let's review Spanning Tree quickly. BPDU Fields, BPDU contains page ID. Page ID is used to elect the root page. We can use page ID for root page election. Then we have then BPDU contains sender's page ID. This is the page ID of transmitting page. Cost to the root page or root path cost. Timer values on root page, message age, and the identifier of the transmitting port. These are BPDU fields. Page ID or BID consists of two parts. One is page priority plus MAC address or system ID. It is used to elect root page. And page priority, it is a priority which is assigned to every switch, and it is 32,768 by default. We can change this value. And root path cost is the best path to the root page. Path with the lowest cost will be selected. In other words, if we have higher speed interfaces, then we have lowest cost value, and then we have the shorter path. These are the default cost for our interfaces. If we have higher speed interface, then we have lowest cost. For 1000 megabit interface speed, we have cost of 4, and for 10 megabit interface speed, we have cost of 100. These are the default value. Then we have root page and non-root pages. The root page is the page with the lowest page ID or PID. As I explained before, PID is used to elect root page. Is used to root page election. The ports on root page are always designated port, which means they are in a forwarding state. All ports in root page are designated. Non-root pages. Non-root pages should find shorter path to the root page. The shortest path to the root page is called root port. In other words, non-root pages have at least one root port. We can see root port only on non-root pages. Okay, let's see root spanning tree election process. The spanning tree election process consists of two parts. One is root page election, and the other one is root port election. First, we have to elect our root page, then root port. Okay, a root page election process. When switches are first turned on, they will send configuration BPDUs containing the BIDs. With each switch initially behaving themselves to be the root page. At the first, all pages think that they are root page. However, when switch receives a BPDU with a superior PID or lowest value, that switch will stop originating configuration BPDUs, and instead they relay those super BPDUs to its neighboring switches. BPDUs follows from root page downward to other switches. Okay, in other words, the switch with the lowest value, with the superior BPDU or lowest value will become root bridge, and BRD consists of bridge priority and MAC address. The lowest speed will become this switch with the lowest BRD will become root bridge. Then we have to elect our root port. Root port has the lowest path cost to the root bridge. To the root bridge. If the path cost is the same, the switch will select the port with the lowest sender bridge ID. And if the sender bridge ID is the same, then lowest sender port ID will be elected. This is the tiebreaker for a tiebreaker. And port priority is by default this value, and port number is the switch interface number. This is how root port is elected in spanning tree. The lowest path cost to the root bridge is root port. Okay, this is another. Okay, now we can understand what is root port. We have root port only on non-root bridges, and root bridges always have the port in designated. All ports on root bridges are designated. Okay, now let's repair spine tape BPDUGuard and RootGuard. Okay, BPDUGuard makes sure that whenever a switch receives a BPDU on an interface, that interface will go into error disabled mode. It will disable a port upon receipt of BPDU. To enable it on interface, we can use the spine tape BPDUGuard enable command, and we can also enable BPDUGuard globally for all interfaces or in access mode. We can use spine tape portfast edge default command, and to enable globally on all interfaces that have portfast enabled, we can use spine tape portfast BPDUGuard default command. And to configure our recovery options, we can use errdisable recovery commands. For verification, we can use show spine tape summary. This is just command for BPDUGuard. Then we have a spine tape RootGuard. It is used to protect root bridges. As we know, root bridges ports are all in designated port of the state. The job of RootGuard is to protect our root bridges. Expanded RootGuard is a feature that prevents a port from becoming a root port. The RootGuard ensures that the port on which RootGuard is enabled is the designated port. It will keep our designated port. When a port is enabled as RootGuard, it cannot be selected as root port even if it receives superior BPDU. If the page receives superior BPDU on a RootGuard enabled port, RootGuard moves this port to a root inconsistent STP state. And root inconsistent state is effectively equal to listening state. Okay, BPDU will disable or if we see BPDU on, if we enable BPDU on our interfaces, and if we receive BPDU, that interface will go to errdisable mode. But in RootGuard, the interface will go into root inconsistent STP state. So these are the differences between RootGuard and BPDUGuard. We can configure BPDUGuard globally and in interface level, but we can only configure expanded RootGuard in interface level. To enable on interface, we can use expanded guard root. Okay, these are our spine concept for this section. We have to understand what is expanded RootGuard, BPDUGuard, and how we can configure these features. Okay, let's configure this section. Configure switch 1, 2, 3, and 4 to disable all edge ports if a BPDU is received, and use a single command to accomplish this. We have to configure these switches to disable edge port if a BPDU is received. Okay, here let's it means to disable all edge ports if we receive a BPDUs, and we can use single command to accomplish this. Okay, edge port means ports are in ports. This edge port is portfast. This is our portfast, and for this we have to use BPDUGuard. BPDUGuard job is to when a switch is a BPDU on the internet, that internet will go into error disabled mode. This will disable our port. And so we have to edge port, and then to enable globally on all interfaces that are portfast enabled. This is edge ports. Portfast is edge port. We can use this command. Expanded portfast BPDUGuard default. We have to use expanded portfast BPDUGuard default on all switches here. pause. Okay. Config T, spanning T. We have portfast, edge, BPDUGuard, and default. Okay, this is the new command. To enable globally on interface that are portfast or edge ports. This is point T, portfast, edge, BPDUGuard, default. Okay, this command will disable all edge ports if BPDU is received. We have used single command. This is spine T, portfast, edge, BPDUGuard, default. This is the job of BPDUGuard. Whenever it's BPDU on interface, that it will go to errdisable state. Okay. Okay, in the event that the BPDU is received on these ports, switch 1, 2, 3, and 4 should re-enable the disable port every 30 seconds. Okay, we can achieve this by recovery options of BPDUGuard. We can use errdisable recovery command to accomplish this part. Okay, now let's configure this errdisable. Then we have recovery. Then we have to configure our cause. Cause is BPDUGuard. And it says it should re-enable the port every 30 seconds. Okay, then we have disable recovery, and our interval is in second, and we have our type simply second 30. Do the showdown. This is on switch 2, switch 3, and switch 4. Okay, this is our job. The switch T should have all its ports in forwarding state for all VLAN in the split domain. Okay, T should have all its ports in forwarding state. It means all ports are in designated. All ports are designated ports. It means that such T should be become with bridge. Should with bridge. We have to make such T as with bridge. Okay, now let's check. Show spanning tree vlan 5. Okay, switch 4. We are blocking forward. It is not root. Show spanning tree vlan. We have root designated an alternative. It is not root. Show spanning tree vlan. We have designated root and show spanning tree vlan 2 to 5. Okay, we have designed switch 1 is our root switch. This is because all of its ports in designated port and forwarding state. Our cost is 100. The default cost value for our interfaces. We have to make switch T as root. We can config T. Spanning tree. Then we have for vlan. For all VLANs. Then we specify root and primary. Okay, now let's check our now. We have now I have designated an alternative and I'll switch to show spanning tree. Let's check VLAN 1. VLAN 1 and all of my ports are in designated port and forwarding state. And if we check here, this page is the root. Now switch T is our root. I'll check switch 1. I have root ID and this port is root port. Ethernet 0/1 is our root on switch 1. Okay, now let's start to show CDP neighbor. Ethernet 0/1 is connected to switch 3. Okay, this is done. Okay, if switch 3 receives a superior BPDU on any of its term ports, it should transition the term to an inconsistent state. Okay, it is if switch port receives superior BPDU on any of its term port, it should transition the term to an inconsistent state. Okay, we have inconsistent state in BPDU RootGuard. Let's find the RootGuard feature. Let's use RootGuard. In other words, we have to keep all designated ports. It's just we have to make sure that switch 3 will always become root bridge. Okay, let's see. Show interface trunk. Okay, it is 0/1 interface range. (0/1) then Ethernet 1/0 till 1. And we have port channel 23. And we have to enable this command here. To enable spanty RootGuard, we have to use this command: spanty guard root. Spanty guard root. Spanty guard root to guarding interface. Speed. And for do show span and show spanty vlan number. It will keep all of my root 0/1 1/0 0 1/1 and port down. This command will keep our designated port on root page. If I receive super BPDU, it will go into the port will go to inconsistent STP state. and routing consistent state is equal to listening state. Okay, this is done. And compare switch 2 and switch 4 so that switch 2 transits switch 4 to reach switch 3 instead of using port channel. Okay, let's verify. We have to make sure that switch 2 transits switch 4 to reach switch 3 instead of using port channel 24. Okay, let's see switch 2 show spanning tree vlan number 1. Okay, now you can see switch 2 is using port channel 23 as root port to reach switch 3. Switch 3 is our root bridge. Switch 3 is our root bridge, and it's port on designated, and switch 2 is using port channel to reach root bridge. And then we have to make sure that switch 2 is we have to make sure that switch 2 uses switch 4 to reach switch 3. Okay, let's see. Show CDP neighbor. Show CDP neighbor on switch 4. This is Ethernet 0/0 and 0/1. And podcast of we have to lower this cost value. This is switch 4, and on switch 4 let's see, show spanning tree vlan number 1. Zero slash 0 and 0/1. Okay, I have to lower this interface cost 0/0. So 0/0. Okay. Okay, let's go on interface. Config T interface Ethernet 0/0, and I tap spanning tree cost. The lowest cost is 1. Config T interface Ethernet 0/0, and spanning tree cost is 1. Now let's do show spanning tree vlan number 1. Let's change the other cost either. Show CDP neighbor. Let's see our show the channel. Show the channel summary. Port 0/2 and 0/3 are bonded in the take channel. Switch to I will make this port on higher value. We're spanning tree cost 1. Switch to interface 0/0. Spanning tree cost 1. I will hire this cost value. Interface port channel (23) and spanning tree cost 200. Interface put that channel 20 expand the cost 200. Now show expand the vlan 1. Okay, now I have found the issue. Let's see what was the problem. Okay, now if I check, if I do show spanning tree vlan number 1, switch 2 is using port channel to reach switch T. Switch T is our root bridge. Then we have facial topology here. We have these two interfaces between switch 2 and switch 3 are in port channel. If I type port channel here, if I do type show the channel summary, I have Ethernet 0/2 and 0/3 bonded in port channel. If I check on switch 3, there show the channel summary, I have these two ports bundled into port channel. Okay, to make sure switch 2 will use switch 4 to reach switch 3, I have to change one of these interfaces between switch 2 and switch 4, and change one of the interfaces between switch 4 and switch 3, and lower these interfaces expected cost to 1. I will use Ethernet 0/0 between switch 2 and switch 4, and Ethernet 1/1 between switch 4 and switch 3. Okay, let's check now. Show spanning to vlan 1. It is not using port channel. Now let's change. So STP neighbor between one of the interface. I will use this interface between switch 2 and switch 4. Config T interface Ethernet 0/0, and I will lower span to cost to 1. And on switch 4, want to show CDP neighbor I have to one of the interface between switch 4 and switch 2. I will use this interface Ethernet 1/0. I will type spanning to cost 1. Now if I check my spanning tree, show spanning tree VLAN number 1, and now it is using switch 4 to reach switch 3 instead of port canal. Our port canal is unblocking stuff. And 0/0 is our switch 4. Okay, that's it. And shut down unused port between switches. Okay, this is it's not important. But that's it. I hope you have enjoyed this video, and thank you for viewing.